We're going to do our distributive property notes. First, you are going to do your warm-ups for the first two frames. So we have this one where we evaluate these two problems below. So we're going to learn today that there's multiple ways of solving problems, and then we're going to name the properties illustrated here in our warm-up. So hit pause and take care of business. Alright, when evaluating my problems in here, 10 times 3 plus 2 in parentheses, we know that we add what's in our parentheses first. We know that 3 plus 2 gives us 5, and we know that 10 times 5 gives us 50. Let's take a look at this next problem over here. Pemdas tells us that we have to multiply before we add and subtract. So we multiply 10 times 3, we get 30. We multiply 10 times 2, we get 20. 30 plus 20 gives us 50. The bottom question asks, how is the problem on the left related to the problem on the right? They both have the same answer. They're equivalent. The 10 times 5 over here and the 30 plus 20 over here are different. These problems look different, but notice how we both get the same answer. Let's take a look at our next part, the distributive property warm-up to match our terms below, or to write our terms below. Our first property is our commutative property because we move our 2 up front and we move our 3 behind the addition sign. Properties of math basically tell us what to do. They're kind of like laws or things you can do in math in order to solve for a problem. So let's take a look at our next one, 3 times 0. Is our 0 property of multiplication, meaning if I multiply anything by 0, my answer is always going to be 0. Let's take a look at our next one. We're multiplying there too. We call it the identity property of 1 because we're multiplying by 1, and every time we multiply anything by 1, the rule is it's always itself. Your answer is always going to be itself. So if I multiply 5 by 1, I get 5. Let's take a look at our last one. Looks like we are shifting our parentheses to different areas. That is our associative property. We are associating 6 and 2 over here, but since there's an addition sign there, I can associate my 3 in front of that parenthesis. So I can associate my 3 with my 2 on my other side. So I can move my parentheses to associate different numbers because of that plus sign there. Let's take a look at our next frame and answer some of these questions. Our first one is, what does the word distribute mean? It means to give out evenly. What's the rule for our distributive property? The distributive property states that numbers added or subtracted within a set of parentheses can be multiplied by a number outside of the parentheses. So let's take a look at some examples. Here in this example, it shows that I have 3 and there's nothing here, so we're going to assume that there's a multiplication symbol there. These parentheses also mean that we're multiplying, so I have to multiply 3 times what is in these parentheses. So my distributive property says I can distribute my 3 to 4, so it's 3 times 4, and I can also distribute 3 to 6 to get 3 times 6. And I can't forget that I'm adding, so I'm bringing down that symbol as well. So let's solve. We can solve by multiplying 3 times 10 because I added my 4 and 6 to get 10, and I'm now multiplying 3 times 10. That gives me 30. Now let's try solving with Pemdas down here. When I multiply 3 times 4, it gives me 12. When I multiply 3 times 6, that gives me 18. Don't forget, I have to bring down my plus sign. My answer for 12 plus 18 is also 30. Let's try our next one. Pemdas tells me I do what's in parentheses first, so 8 minus 3 gives me 5. And then I multiply 2. 2 times 5 gives me 10. Now I can do the bottom and give that one a shot. 2 times 8 gives me 16. 2 times 3 gives me 6. Don't forget to bring down my operation that's left over. And now I solve. 16 plus 6 gives me 10. Notice how if I distributed 2 times 8, I get 2 times 8. Notice how I distribute 2 times 3, I get 2 times 3. Okay, so all we did was we distributed, and that's why we have the same answer. Same goes here. I distribute 3 times 4 down here. I distribute 3 times 6 down here. And notice how, even if I distribute, I have the same answer. That means that my distributive property gives everything out evenly because it gives me the same answer every time I distribute. Okay, so here I associated, and then to distribute means to give it out. So I gave the 3 out evenly to my 4 and my 6, and I gave the 2 out evenly to my 8 and my 3 over here. Let's take a look at an algebraic example. So let's look at A times B plus C. This is a concept that we are learning today. We sometimes have known numbers that we can solve for and get an answer for. Sometimes we won't have an answer, we'll have variables. Okay, this is called algebra, or pre-algebra is what we're learning right now. So I'm going to distribute the A to my B and the A to my C. So I have A plus B, A times B, because I'm multiplying A to B, and now I distribute it to my C, so I'll have A times C. My operation is a plus. That's what separates my terms from each other. That is my answer for an algebraic example. Now let's try one where we have to subtract. Same thing. I distribute my A to B for A times B. I distribute my A to C for A times C. And I bring down that operation, always. For our number 5, we can simplify our algebraic expressions. So the distributive property can be used to simplify our algebraic expressions. So let's try some of these examples here. Okay, so now we have algebraic expressions, we have variables, we have constants, and we also have coefficients. So let's distribute that first one. 5 gets distributed to 2x to become 5 times 2x. Bring down that plus sign. And 5 distributes to y as well to create 5 times y. So let's simplify this term. 5 times 2x gives me 10x, and 5 times y gives me 5y. Let's try our next one. We're going to distribute 6 to 3a, and then we're also going to multiply 6 times 2b. 6 times 3a gives me 18a. Don't forget to bring that subtraction sign, and 6 times 2b gives me 12b. Let's try our next one. We're going to distribute our 10 to a 2g to an H, and also a 1. Remember, when there's an operation in the middle, that means that these are all separate terms we have to distribute to. So my 10 times 2g gives me 20g. 10 times 1h gives me 10 h's. And 10 times 1 identity property gives me 10. Notice how my symbols don't change. Okay, and here I'm distributing 7 to w, 7 to 2x, and 7 to 2. 7 times w gives me 7w. 7 times 2x gives me, 14 x, and 7 times 2 gives me 14. Now you're going to practice with a star in the equation. Problem says write the value of a star in the equation below. How do I get my answer, 25? I know I have to multiply 5 times 3. I know that's going to give me 15. Plus, what else is going to give me 25? That would be a 10, right? So now I divide that by 5 to get my answer. My answer is 2. That's what my star is. Let's try our next one. Write the value of the star in the equation below. 3 times 6 minus 3 times 3 equals star. This is an easy solve. 3 times 6 gives me 18. 3 times 3 gives me 9. Bring down my subtraction sign. 18 minus 9 is whatever star is, and here my star equals 9. The problem below says simplify the expression below using the distributive property. So now I'm going to distribute my numbers. So I'm going to separate my 86 into numbers that I can manage. I'm going to do 80 and 6 because 80 is an even 10 number, 6 is an even number. So this makes it a clean cut. Now makes it easier to solve because now I distribute 3 to 80 and 3 to 6 to make 3 times 80 and to make 3 times 6. Now I multiply 3 times 80, that gives me 240, and then I multiply 3 times 6, that gives me 18. So in total, my answer is 258 to answer the problem. Same goes for number 4. Simplify the expression below using the distributive property. So I'm going to use my distributive property because 7 times 23 is a really big number. I'm going to separate them to my 10s, 20 10s, 3 1s. Then I'm going to distribute. 7 to 20 gives me 7 times 20. 7 distributed to 3 gives me 7 times 3. Now I can solve. 140 plus 21, that gives me 161. Let's take a look at number 5. So simplify the expression below. We're going to distribute our 8 to 2k and our 8 to 7m. 8 times 2 gives me 16k. 8 times 7 gives me 56m. Number 6 says simplify each expression below. Again, I'm going to distribute my 9 to my 2g and my 9 to my h. 9 times 2 gives me 18g, and 9 times 0, or this invisible 1, gives me negative 9h. And now I can solve. 18g and 9h cannot be solved any further because there's different variables, so they're different terms, so that is my final answer. My answer is 14 plus 21g, and for number 8, my answer is 4f plus 2g minus 2. Make sure you do your exit slips and you will be all finished.